Hello students, welcome to Eshwari channel. Students, in this video we are going to learn the law of chemical equilibrium. So consider equation A plus B giving C plus D. So this is the arrow mark which represents it is a reversible reaction. So conversion of A plus B to C to D is called as forward reaction. Forward reaction. C and D reacting to form A and B will be backward reaction. Backward reaction. So now let us apply law of mass action. Law of mass action. So what does the law of mass action says? So see here, the law of mass action says rate of a reaction is proportional to product of active mass of the reactant. So rate of the reaction depends on what? Active masses of the reactant. So we will write rate of a reaction for forward reaction, that is R is rate for the forward reaction. So rate of forward reaction will be proportional to product of active masses of the reactant. Here the reactants are A and B. So active masses, students, we have to write in square bracket A, B. Same, let us write for backward reaction. So rate of backward reaction is directly proportional to. So proportional to what? Active masses of the reactant. So students, backward reaction, if I have to write separately, it will be like this. C plus D giving A plus B. So this is backward reaction. So here A, C and D will be reactant and this will be product. So for the backward reaction, reactants are C and D. So directly proportional to C and D. So now rate of forward reaction. So proportionality sign, if I have to remove, I have to insert a constant. So constant will be Kf. So what is Kf? Kf is nothing but rate constant for forward reaction. And then write this as it is, A, B. Same, rate of backward reaction will be equal to constant, rate constant for backward reaction C into D. So this is B. So here this is nothing but rate constant. Rate constant for forward reaction. Forward reaction. And KB will be rate constant for backward reaction. Backward reaction. So next, at equilibrium. At equilibrium. So students, we know at equilibrium rate of forward reaction will be equal to rate of backward reaction. So this is what we learnt in the first class. So what we learnt is at equilibrium the rate of forward reaction will be equal to rate of backward reaction. So now rate of forward reaction is, substitute the values for rate of forward reaction, which is Kf A, B. This is equal to rate of backward reaction is Kb, active mass of C and active mass of D. So next step, bring this to the denominator. So it becomes Kf by Kb is equal to CD divided by. So this one you bring to the denominator. So it becomes A, active masses of A, then B. So now Kf by Kb, let us take it as Kc. So now This is represented as Kc. Kc is equal to Cd divided by active masses of A and B. So students, what is Kc here? Kc is called as equilibrium constant. Equilibrium constant. So here what we have written, equilibrium constant is equal to active masses of the product. C and D are products, you can see here. So active masses of the product divided by active masses of the reactant. So now we will take one general equation, A and then B giving C and D. So students, here A, B, C and D. So these are called as stoichiometric coefficients. So now when you want to write Kc, Kc is equal to active masses of the product. Here product are C and D. So C, so this stoichiometric ratio you have to, stoichiometric coefficient you have to write in power. C and then D, and this will be power D divided by A, small a, B, stoichiometric coefficient you have to write in power B. So this is the expression for equilibrium constant. So this is what the law of chemical equilibrium states. So what the law of chemical equilibrium states is, see here, at a given temperature. So the law of chemical equilibrium states at a given temperature the product of concentration of the product. So see here, the product of concentration of the product raised to their respective stoichiometric coefficient. So you have to write stoichiometric coefficient in their power in a balanced chemical equation divided by the product of concentration of reactants. So you are dividing this by concentration of the reactant. Reactants are A and B raised to their individual stoichiometric coefficients which has a constant value. So here write product raised to their stoichiometric coefficient divided by concentration of the reactant raised to their stoichiometric coefficient. So you will be getting the answer as a constant, which is equilibrium constant. So this is what law of chemical equilibrium states. So now let us take some example and write equilibrium constant for that reaction. So first reaction, N2 plus 3H2. So this is in the gaseous state giving 2NH3 gas. So students, here the question is you have to write equilibrium constant for this. Kc is called as equilibrium constant. So how to write? Kc is equal to, first you have to write product. Product is NH3 raised to their stoichiometric coefficient. So here the stoichiometric coefficient will be 2 and here it is 3. If there is no number, it means here it is 1. So stoichiometric coefficient is 2 divided by reactants. Reactants are nitrogen raised to power 1, or you can just write En2. Hydrogen, stoichiometric coefficient is 3. So this is how we write equilibrium constant. One more example. So this is from the textbook. 4 times ammonia gas, 5 times oxygen gas giving 4 times NO gas plus 6 times H2O gas. So write equilibrium constant for this. Okay, you have to write the expression. So Kc is equal to, write the products first. So here stoichiometric coefficient 4, 5, 4, 6. So these are stoichiometric coefficients. Write the product NO stoichiometric coefficient, write in the power. Next, H2O power is 6 divided by ammonia power 4, oxygen power 5. So this is the Kc expression for this equation. So students, now, so let us take some more examples. So students, these are the questions I have taken from from your textbook, NCERT textbook. So write the expression for Kc. So first one, let us write for this. So here stoichiometric coefficient is 2, and here if there is no number, it means it is 1. So Kc is equal to, so product will be NO power 2 and then Cl2 divided by, if there is no number, it means it is 1, divided by NOCl reactant to the power of 2. So this is first one. Second one, so students, here one thing what we have to remember is active mass of pure solid and active mass of pure liquid will be constant. So we are taking the value as 1. So active mass of pure solid and pure liquid value will be constant. That is why we are taking it as 1. So here, so wherever we see solid, so in this equation, wherever we see solid, so this will be 1. We are not going to write this in the equation. So here copper oxide solid, so this also it will be 1. So now Kc is equal to, so solid and liquid don't write in the expression because its value will be 1. So leaving that, only the gases we will write. So it is NO2 4 times, NO2 4 times and oxygen 1 time. So divided by this, so this is solid, we are not writing. So this is the expression for second one. Third one, so see again here pure liquid. So here this value will be 1. So we are not writing in the expression. Don't write it in the expression. And aqueous we can write. So only the pure liquid and pure solid we are not writing. So third one, Kc will be equal to, so here this is the product CH3COOH. So stoichiometric coefficient is 1. So there is no need to write power 1, it is understood. Then C2H5OH divided by, so divided by, in the reactant we have this CH3COO C2H5. So this is the expression for Kc. Next, fourth one. So fourth one, so you can see this is solid, FeOH3, this is solid, so it becomes 1. No need to write in the expression. So Kc is equal to, so the value will be 1, so write 1 divided by, write the reactant Fe3 plus and then OH minus power. So here this is the stoichiometric coefficient, so to the power of 3. Fifth one, so here I2 is solid, so its value is 1, so no need to write in the expression. So leaving this 2 we can write. So Kc is equal to, here the stoichiometric coefficients are 5 and 2. So IF5 stoichiometric coefficient is 2 divided by F2 stoichiometric coefficient is 5. So this is how we write the expression for Kc. Kc is equilibrium constant. So now some more important concept about equilibrium constant we are learning. So the first important concept is first one, equilibrium constant for reverse reaction is inverse of equilibrium constant of forward reaction. So students, this is very important. See here, questions will arise in NEET examination like this. See the first question what I have taken, this appeared in 2015. Then one more question, see here the second one. So this appeared 3 times in NEET examination, 2017, 2003, 2007. So these questions we can solve only using this concept. So let us learn that concept. So here equilibrium constant for a reverse reaction is inverse of equilibrium constant of forward reaction. So this one is very important, it is inverse. So what is the meaning of this? So students, let us take one example. A gives B. So here let us take equilibrium constant for this reaction as K1. So now reverse this reaction. Reverse means B giving A. So what is the equilibrium constant for this reaction? So here it says equilibrium constant for reverse reaction is inverse of equilibrium constant of forward reaction. So if forward reaction is K1, if you reverse, it becomes inverse. Inverse means reciprocal. So it will become 1 by K1. So this is the concept, first one. Second is reaction when multiplied by, so when multiplied by any number, what happens? So we will take that number as n. So what will happen to K? So we will take one example. So students, here A gives B. Equilibrium constant for this reaction we will take it as K1. So now multiply by n. So n can be any number, it can be 1, 2, 3, 4, half, it can be any number. So I'll be multiplying this reaction by n. So it becomes Na, Nb. So now what will be the equilibrium constant? Equilibrium constant will be K1. For A to B it is K1. When you are multiplying this reaction by n, then equilibrium constant, to that you have to write the power. So the number what you have multiplied, so that should be written here in the form of power. So it becomes K1 to the power of n. So this is second concept. Third, if two reactions are added. So when two reactions are added, what happens to equilibrium constant? So let us take one example. A gives B. So let the equilibrium constant be K1 for this reaction. Another reaction, B gives C. So for this, K2 is the equilibrium constant. So now we are going to add this equation. So add equation 1 and 2. So when you add, B and B will get cancelled. So you will get A giving C. So what I have to do with the equilibrium constant? So what I have to do is, I have to multiply this. So here it will be K1 into K2. So you have to multiply equilibrium constants. So when you will multiply, when two reactions are added, when you are adding two reactions, then equilibrium constant should be multiplied. Next important concept, fourth one, if two reactions are subtracted, what happens to equilibrium constant? So let us take example A giving B. Let the equilibrium constant be K1. C giving D. This is second reaction. So let the equilibrium constant be K2 for this. So now subtract this. So subtraction. So when you subtract, here negative sign and here negative sign. So it becomes A minus C giving B minus D. So this is the reaction. But what happens to equilibrium constant? So the equilibrium constant you have to divide. So it is K1 divided by K2. So if two reactions are subtracted, you have to divide the equilibrium constant. So this is the concept we have to learn. So in order to solve this problems. So now let us solve this equation, this questions which appeared in NEET examination. So first let us solve first question. First question, this appeared in 2015. If equilibrium constant for, so here a reaction is given and equilibrium constant is given as K1 for this reaction. Find equilibrium constant for. So for this equation we have to find equilibrium constant. Four options are given, A, B, C and D. So now this is the this is the equation given. So we have to find equilibrium constant for this. So compare this with this equation. Here you have N2, here you have half N2. So here O2, half O2. Here 2NO, here 1NO. So what is happening is, if we multiply this equation by half. So if you multiply this equation by half, what you will get? Half into N2, half N2. Half into O2, half O2. Half into 2. So 2 and 2 will get cancelled. So you will get only NO. So what we are doing is, we are multiplying this equation by half. So when you multiply, what did I say? If you multiply any number, see here, when the reaction is multiplied by any number, if you are multiplying by any number, that number should be raised as power to the equilibrium constant. So now here we are multiplying half. So that should be raised to the power of equilibrium constant. So equilibrium constant is K1. So power number what we have multiplied is half. So it should be written in the form of power half. So see in the question whether it is given. So here you can see half K. So here this will be K. This is just take it as K because here it is given as K. So half K, K square and K to the power of 1 by 2. So K to the power of 1 by 2. So this is the correct option. K to the power of 1 by 2. Second question. So second question here, three reactions are given. For that K1, K2, K3 is given. So what you have to do is find equilibrium constant of. So for this, For this reaction, we have to find equilibrium constant. So 4 options are given. So let us find now. I'll write the equation. So this equation I'll write first. 2 times NH3 plus 5 by 2 O2 giving 2NO plus 3H2O. So this is the equation for which we have to find equilibrium constant. So students, first I will analyze what is given here. 2NH3 is required. So in this 3 equations, see where is 2 times ammonia. So I can see here 2 times ammonia is present. So it is present on the product side, but I want it on the reactant side. So what I have to do? You have to reverse the equation. So this equation 1, I'll take this as equation 1, this as equation 2, and this as equation 3. So reverse equation 1. So if you reverse, what you will get? You will get 2 times NH3, 2 times NH3, N2 3H2, N2 plus 3H2. So what will be equilibrium constant? If I reverse the reaction, equilibrium constant you have to take reciprocal. So here it will be 1 by K1. Now second. So next I will see here. So here I have oxygen. So oxygen is there in 2 equation. So next we will go for 2NO. So 2NO is on the product side. So in this 3 equation, you can see 2NO is present here on the product side. So second equation, write as it is. So equation 2, write as it is. There is no change. N2 plus O2 giving 2NO, because we need 2NO and it is there 2NO. So next what we require is 3 times water. See in third equation, water is present, but it is only 1 time. How many times we require? We want 3 times water. Therefore multiply equation 3 by 3. So multiply equation 3. So you are multiplying by number 3. So it becomes 3 into H2, 3H2 plus 3 into half. So it will be 3 by 2 O2 giving 3 into water. So 3H2O. So here second equation, rate constant will be same. So I have written as it is. So it will be K2. So for third one, what will be the rate constant? I have multiplied by number. So I have multiplied by 3. So if I multiply by 3, what we have to write in rate constant? We have to write that in power. So K3. So K3 is the rate constant. And to this we have to write power 3. So now next step is add all the equations. Add all the 3 equations. So when you add all the 3 equations, what will happen? Nitrogen will get cancelled. 3H2 will get cancelled. So remaining what you will get? 2NH3 plus oxygen you have to add. Here 1 time oxygen plus 3 by 2 oxygen. 3 by 2. So 1 plus 3 by 2, how much you will get? So LCM is 2. So it becomes 2 plus 3, which is equal to 5 by 2. So you are getting 5 by 2 O2 giving 2 times ENO plus 3 times H2O. So whether this is the equation what we require. So check 2NH3, 5 by 2 O2, 5 by 2 O2, 2NO, 3 water, 3 times water. So we got the required equation. So now what we have to do is, we have, see here, we have added the equation. So when we add the reaction, what we have to do with the equilibrium constant? See here, when reactions are added, you have to multiply the equilibrium constant. So multiply the equilibrium constant. This one and this one. So we have to multiply. 1 by k1 into k2 into k3 to the power of 3. So multiply this, you will be getting k2 k3 to the power of 3 divided by k1. So this is the answer. So let us check whether this is given in the options. So here you can see these are the 4 options. So k2 k3 to the power of 3, k2 k3 to the power of 3 divided by k1 divided by k1. So first option is the correct one. So students, is that clear? So in the next video we will continue further.